Hello. So, where we ended in the last class of reactive intermediate series or carbocation series, our next discussion is H plus water addition. This is a very simple reaction, but in some examinations, they go some deeper. Okay. So, very basic things are so common that examiners nowadays don't ask those. So, we have to look upon deeper or critical problems. For that, you will look in this video. Okay. So very basic things, one or two very basic themes I will discuss first, and next we will go to advanced problem and we will observe some special cases of this. Okay. So the sources I'm following is one or two sources I am giving. There is Claydon, Carothers, N. Tiwari, Peter Sykes. These are some basic books which I have followed to make my notes, and from my notes I am actually teaching you. I make notes actually combining four or five books. Whenever I study a topic, I take five, six standard books and I read the particular topic from all of them and make my notes. Okay, so from that only I am teaching you so that every aspect of this topic is covered. Okay, okay. So let's get started. H plus water addition. Basic thing is, if you have given one alkene, suppose this is my alkene. Okay, we are giving H plus source, proton source. That means any acid. An acid is diluted actually in water medium. Okay, with water it is diluted, so H plus water. Sometimes water is not written. Okay, so H plus, what will happen? This H plus, there is positive charge, so this is electrophile, and this system has pi electron cloud, so this is actually nucleophile. So nucleophile attacks electrophile, so this double bond, this pi bond will attack from this carbon or this carbon to that electrophile. So from this carbon, suppose this is attacking. Okay, if I am taking some unsymmetrical system for better understanding. Okay, so let me remove this. Okay, this is our alkene. Okay, so from this center, from the left center, this nucleophile can attack to H plus, or another possibility is from right center it can attack. From left center it attacks. So then we get this center is connected to that hydrogen. Okay, and this center, the double bond will break and this center will get positive charge. If this attacks from this center, right one, this right one carbon, so hydrogen will attach to this carbon, that is a 1 2 C2 carbon. So hydrogen will be attached to C2 carbon, and alternatively the another carbon will be getting positive charge. Now we are actually getting two different carbocations. So we have to simply observe which carbocation is more stable. So for this, first we will observe at hyperconjugation. So here you have to use GOC concept: aromaticity, resonance, hyperconjugation, inductive effect, etc. Okay, dancing resonance, etc. So all of this you have to consider. So here we can see that this center is 3 degree, this center is 2 degree. Here hyperconjugation, here no resonance, nowhere is no resonance. So we have to consider hyperconjugation. Here 3 plus 3 plus 2, 8 hyperconjugative structure. Here 3 plus 1, 4 hyperconjugative structure. So first one is more stable. First one, if I write in a proper way, this is this carbocation. Okay. Now if water is given, so we have next nucleophile water will attack. In system we have water. Okay. Now water is nucleophile, and now this system has become electrophile, the carbocation. So this will attack simply. Water means actually OH will attach. OH. So this is going to be our final product. But the problem is, whenever the carbocation is formed, if there is any possibility that it can rearrange to form better carbocation, that is from rearrangement, from ring expansion, contraction, anything, then that will definitely occur. And after that rearrangement, water will attack to give final product. So here, no such cases are possible. So these are going to be final product. Now, this H, so this is a two-step reaction. Okay. So step one, step two. Here, step one is rate determinating step, that is slow step. Why step 1 is slow? Because neutral molecule is giving one carbocation. Okay, neutral molecule is giving one carbocation. So neutral stable molecule to unstable species. You can think of that H plus is also cationic, so charged species. So it can also be in kind of less stable system. So I am saying that nucleophile more stable, uh, this neutral species is giving carbocation. This is more stable to less stable conversion. No, actually H plus is in water medium, so water is hydrated in a very efficient way. Okay, this is actually H3O plus. Okay, that's why this is a stable system. Hydration energy is so much, so this is very much stable. So one stable system is giving one unstable system, so this is redeterminating step. And the second step, less stable carbocation, that is charged species, is giving and again a neutral species. That is, again this step will be fast because charged species is going to give neutral species, so less stable species is going to give more stable species, so this is fast. So this is the important part, which step is RDS, redeterminating step. Okay, now let me give you some questions. Okay, let me give you some questions. This is the basic concept you have understood. Now apply this. Mm, question is, in every case you have to first write the question uh, and try to solve yourself. So first pause the video and try to solve yourself and then come to the answer. Okay, the question is H plus water. This methyl is not actually above the group, so I have marked 2 or 3 times, so this is assuming, so consider it without stereochemistry. Okay, it is your question. Now how you will approach, first try yourself, then come to the solution. Whatever you will do, first you have to make carbocation. So from this center, if H plus approaches, H plus attacks, then this center will be getting positive charge. So first carbocation possibility is this. Second one carbocation possibility is this. Now, which one is more stable? Here, uh, 2, 2 plus 1, 3 hyperconjugative structure. Here, 2 plus 2, 4 hyperconjugative structure. Now, the tricky part here is, if you think that, obviously you will think, you are smart enough, that in this structure, if we can perform a hydride shift, then my carbocation will get converted to this 3-degree one. Then it will give 3 plus 2 plus 2, 7 hyperconjugative structure. Will this occur? Will the reaction proceed through this carbocation? Answer is no. First, you have to choose more stable carbocation among the two possibility, between the two possibilities. From that, you have to take the more stable one, and if this system undergoes rearrangement to form a better carbocation, more stable carbocation, you have to do that. Okay, otherwise you don't have to consider this one, not this one, that means not this rearranged product, even it is more stable than the second one, so you don't have to consider this. So now our water will act as a nucleophile, and our final product will be simply this. This will not form, this will not form. Okay, hope you have learned the concept very well. Okay, next, question 2. Again, pause the video after I write the question and try yourself. Question is, it is above the plane, the left methyl is above the plane, and you are giving H plus methanol. Similar way, the similar way water attacks, methanol will attack in a similar way. So instead of OH, OMe will be attached. Okay. Now, question is here P plus Q, two product will form. Question is what is the relation between them? Homomere, enantiomer, diastereomer, constitutionally heteromer. Four options. Homomere, enantiomer, diastereomer, constitutionally heteromer. Constitutionally heteromer means constitutional isomers. Okay. Now, let's solve the question. We know two possible carbocations are there. Here you will learn another concept. Okay. Now, this will give two carbocations. First one is this. Second one is this. Okay. Now, if you separately add OMe, that is methanol, to this position and this position, these two structure forms constitutional isomers. Okay, that is positional isomer. Okay, so answer should be constitutional isomer. If you add separately OMe to this position and this position, they're giving constitutional isomer. But what you have to consider that you have to neglect the less stable one. Here, more stable one is this one. Okay, 3 plus 2 plus 2, 7 alpha hydrogens. So here 2 plus 1, 3 alpha hydrogens. So you have to just neglect it, and we have to proceed. You have to proceed from this only. And this structure is giving basically, we know carbocation is a planar structure. Then water or sorry, methanol can attack from above the plane. So if it is above the plane, then OMe will be above the plane. This methyl will be actually below the plane. Plus OMe can attack from below the plane, and methyl group will be above the plane. So we have to consider these two structure, not these two. Okay. Now what is the relation between them? You can easily tell us. If this center is R and if this center is R, so here structure is RR, and here if this is R, this will also be R because same configuration, but this center configuration has reverted. So reverted, no, not reverted, inverted. So this is going to be this is going to be S. So RR and RS, we know these are diastereomer. So our answer will be diastereomer. Okay. Hope you have understood this. Now one task for you, try yourself, and actually I am giving question and I am writing the answer. You have to come to the answer, okay, by yourself. Not six-member ring, I'm very sorry. Maybe the question is from Caruthers. Again, sorry. Five-member ring. Five-member ring, isopropyl group, and this one, H plus water. What will be the product? Answer I am writing, try yourself, and I am writing the answer. Is going to be a six-member ring. Here methyl, and here OH. Okay. This bond means this can be above the plane or this can be below the plane. So this actually two structure. Similarly, this two product we can write like this: methyl OMe. That means OMe at time above the plane and another structure below the plane. So try yourself. This is going to be your answer. I'm giving you some hint. Okay. First, this center, first this carbon is going to have positive charge. Then it can rearrange. Then it can rearrange from. Uh, this is a difficult. You may find it difficult. So I am again solving this question. Next question I am giving you as homework. Okay. First, this center will be positively charged. This one will be more stable. Another one we have to neglect. Now this can undergo rearrangement. How? This is 3-degree carbocation, but 2 plus 2 plus 1, 5 hyperconjugative structure. If we perform this hydride shift, then we will be getting this carbocation. This is also 3 plus 3. This is 3 plus 3 plus 1, 7 hyperconjugative structure. Now this is 5-member ring. Okay, this is 5-member ring, and now this can convert to this can undergo ring expansion. Okay, so we will be getting this. For these reasons, I have taken extra class for ring expansion, for rearrangement. Okay, so if you have not seen that, please complete previous lecture of this ring expansion to get a good command. So this will be our ring expanded product. Now this is actually having two hyperconjugative structure. Okay, now what will happen? It again can undergo rearrangement. If methyl shift occurs from here, we are getting basically this carbocation, and this is 3 plus 2 plus 1, 6 hyperconjugative structure. So 6-member ring with 2 hyperconjugative structure, and 6-member ring with 3 plus 2 plus 1, 6 hyperconjugative structures. So this is more stable. Okay, now water is going to attack there, and if water attacks at this center from above the plane and below the plane, you are simply getting this product. So in some question, in some tricky questions, they can also ask that how many ring expansion will occur, or how many rearrangement will occur. So you have to consider the steps. You have to know the steps. Okay, otherwise you can't proceed. So next question. Now this question you have to do yourself. I'm not going to tell you. The question is, give your question, mark question number accordingly. Okay, this H plus methanol. This is our question. Okay, now this is going to be our product. This is going to be our final product. Try yourself. Okay, now let's go to the special case. Okay, special case of H plus water addition. Now there is one question I'm writing. OH, this one. If H plus is given here, now there are two possibilities. The alkene can attack to the proton and give a carbocation. Water OH can attack to H plus, and water can remove, and this center can be carbocation. So this center can be carbocation, as well as this center can be carbocation. So deprotonation can lead to carbocation, and H plus addition to alkene can lead to carbocation. Now which carbocation will form? This is a big question. You have to make every possibility. The answer is you have to make every possibility, every possible carbocation, and you have to take the most stable one. You are making, if OH is attacking H plus and then water is removing here, so the carbocation formed by this will be simply this one. But if this alkene attacks to H plus, then the most stable carbocation will be OH, this one. And if you have to wipe out the position of this center attack, okay, this is the least stable one. Okay, from the alkene part, 2 carbocation is possible. We have to take more stable one. Now we have to compare between these two. If external nucleophile is given, carefully remember, if external nucleophile is given, then product will be different, and if no external nucleophile is given, product will be different. From these two, now which one is more stable? What do you think? This is having 2 hyperconjugative structure, and this one having 3 plus 2, 5 hyperconjugative structure, and which is far away actually, uh, to show minus I and destabilizing the carbocation, which is far away. Okay, so 2 hyperconjugative structure, 5 hyper, you have to consider that hyperconjugation only. So this one is more stable. So product is going to be from this carbocation only. But if external nucleophile is given, then nucleophile will attack simply there. But if no external nucleophile is given, in all other cases, what you do? You do elimination and make one alkene. But here you can't do elimination. Here internal nucleophile is present. OH is one internal nucleophile. So what will happen? I am writing that structure again for your better understanding. OH, this is one internal nucleophile. So what will happen? This will attack. Okay. Now a ring will form. How many member ring? One, two, three, four, five, six-member ring. Six-member ring containing one oxygen, and one position is oxygen, and sixth position there is one methyl group. So this is going to be your final product. If external nucleophile is given, then external nucleophile will simply attack there. That will be final product. Leave it. And if external nucleophile is not given, then this will be product. Okay. Hope you have understood this. Next, some more examples, some more tricky part about this. Suppose the question is this one, H plus. Now what will happen? Here from alkene also, here from alkene, we can get the carbocation. This is the question. You can try, and after that you can follow the lecture again. So from alkene, if carbocation is formed, then this will be our carbocation. If alkene participate in carbocation formation, then this will be most stable carbocation, and it is stable by, you can see, plus M. Okay, so plus M stabilization or plus R stabilization. If OH group take part in formation of carbocation, then the product is going to be this one. Fine. So this is not plus M stabilized, right? This is only hyperconjugation stabilized. 2 plus 2 plus 1, 5 hyperconjugative structure. We know mesomeриc effect or resonance effect is more prominent, more stabilizing fact for carbocation. Okay. In the first or second lecture, I have shown you that how these phenomena affect the stability of carbocation. Okay. So this is more stable. So product is going to be from this only. Now, can it rearrange? Yes, it can rearrange. How? This four-member ring can rearrange here to form a five-member ring. Okay. So our five-member ring will be like this, plus OH. So here five-member ring can be from this one. Okay. Now what will happen? This positive charge can be stabilized. This positive charge can be uh, stabilized by back bonding of oxygen. So our final product is going to be double bond O. So this is going to be our final product. Okay. Hope it is clear to you. Another question I am giving for homework. Okay, three-member ring and OH is there. H plus is given. This is your homework, and the answer is simply, not simply, try yourself and find its difficulty level. This is going to be your final product. Again, another question I'm giving it to you. The question is benzene OH, this H plus, and you have to try yourself, and the final product will be coumarin type of compound. There is a type of compound called coumarin. You will learn it in Perkin rearrangement. So this is a coumarin type of molecule. Oxygen is there. Oxygen. This center is oxygen. This is one methyl. This will be final product. Okay, another question you can try. This is a little bit advanced, you can skip it also. This one, H plus water, this is going to give us as final product OH 2 methyl. Okay, so this is actually our final product. So this our H plus water addition is over. Okay, now our next discussion will be HX addition. So we are starting HX addition. HX addition means any acid. H means one cation, that is H plus, and X is one anion, that is X minus. So this is same kind of reaction, but here the thing is, in HX, first H plus will be attacked by our double bond, then X minus is here a nucleophile, then the carbocation will form, and the carbocation will be attacked by X minus. In previous case, carbocation is undergoing attack by water. Okay, now the anion part or the second step, the nucleophile is going to be our X minus. So here is some simple problems are there. One or two simple problems I'm discussing. After that, there is the advanced case also. For simple question like this one, this alkene, HBr. So first you have to make carbocation. So more stable carbocation you have to make. This is more stable carbocation. You can count, you can write the alternative one, and you can count the alpha hydrogens as well, like this one. This one 3 plus 1 4 hyperconjugative structure, and here 2 plus 2 plus 2 6 hyperconjugative structure. So this is more stable, and this is not going to undergo any kind of rearrangement. So X minus will attack to that carbocationate position, and this is simply going to give us this X. So this is going to be our final product. So you can try some more problems. I am giving you, this is a very simple, and simple things we should not invest very much time. Okay, this is our question, HBr, and our product we are getting bromine is there. Okay, so this is going to be our product, you can try yourself. Okay, so first you have to take those two possibilities of carbocation, you have to find the more stable one, and you have to neglect the less stable one, and from more stable part, if any rearrangement is possible, you have to perform that rearrangement or ring expansion, contraction, anything. After that we have to add the nucleophile X minus. Next the question is 5-member ring, this reagent is HBr. Okay, H plus is cation and Br minus is going to be last nucleophile. Our final product is going to form here is Br. This is going to be our final product. So try yourself. Again, next question, homework, you can write. Sorry. 4-member ring. Again, the 4-member ring. So again, HBr is reagent, and you are going to get the product 2 fused 5-member ring, and here Br. Okay, this is going to be your final product. You have to try yourself. This is simple, you have to perform rearrangement, and ring expansion rearrangement you have done earlier also in this kind of system. Okay, so I'm skipping that. The more advanced problem in HX addition is conjugated diene. There are three types of diene actually. One is isolated diene, one is conjugated, and one is cumulated diene. Isolated means alkenes are actually isolated. No resonance is possible. Like this. Conjugated means this and this. This is undergoing resonance. This is undergoing resonance. So this is conjugated diene. And cumulated means carbon, carbon, carbon. So double bonds are in adjacent positions. So these are cumulated dienes. These are actually alene systems. Alene systems. Okay. So this type of diene. Now in isolated diene case, you already know what to do. In conjugated diene, this is important. In isolated diene, you have to take all the possibilities, make all the carbocation, and which one is most stable, take that. And if rearrangement is possible, make that rearrangement and make the final product. If nucleophile is given, add that nucleophile. Okay. And if nucleophile is not given, uh, look upon the internal nucleophile. If in internal nucleophile, then ring closing can occur. Okay, ring formation can occur. Otherwise, add that nucleophile which is given. Like the conjugated system, this is very much special. Addition of HX in conjugated system. First, suppose my question is, I have this diene and I am adding HBr. What is going to be the product? Now, first take one double bond, okay, and perform HBr addition on this. So our carbocation will be this. This will be less stable, right? Because 1 degree. So we have to neglect that. So our most stable carbocation is this. Okay. Now, if this resonance is possible here, like this, so this will undergo resonance like this one. Okay. Now, second structure, it will be called thermodynamically controlled product. This will be called kinetically controlled uh, kinetically controlled product. Why? If first structure, if nucleophile is added, that is Br minus, our product will be this one. If in second structure, uh, we are going to get product that will be this one. Which one is more stable thermodynamically? Which is more stable? So we have to consider the hyperconjugation with respect to that alkene. This alkene has only one hyperconjugative structure, but this alkene has 3 plus 2 5 hyperconjugative structure. So this alkene is more stable. So more stable alkene, that is product is more stable. So this is thermodynamically controlled product. Now, which one will measure in which cases? If temperature is high, then always thermodynamically controlled product. If a room temperature is also given, a room temperature given means a temperature is not mentioned. You have to consider it as room temperature. That is also going to give thermodynamically controlled product. But if temperature is low or very low, then you have to consider that kinetically controlled product will be uh, kinetically controlled product will be major product. So in this question, the question I have written, nothing is mentioned, right? That means room temperature. So room temperature means thermodynamically controlled product, TCP. So after that resonance, this will be our product, and this is going to be major product. Okay. So this is our major product. Okay. So low temperature, actually the low temperature is less than equal to 0 degrees Celsius. 0 degrees Celsius or less than equal to 0 degrees Celsius. This is low temperature. And but better you consider that a room temperature more than equal to room temperature, greater than equal to room temperature, greater than equal to room temperature, you consider it as thermodynamically controlled product. Okay. Now another question I am giving with this concept. The question is, this one HBr. So in the similar way, try yourself. You will be getting this product. This is practice question. Similar question. This is diene system only. right? This is diene system only. Make all the possibilities carbocation and take the more stable one, and after that perform the resonance, and then from resonance more stable carbocation will form. Thermodynamically stable carbocation will be formed, and that is going to be giving you thermodynamically controlled product. So here it is, thermodynamically controlled product will be measure. What will be kinetically controlled product? Kinetically controlled product will be this one. Okay, it is KCP. Here in this case, it will not be measure. Okay, but if temperature if is very low, then this is going to be measure product. Another name is given to this two type of product. In thermodynamically controlled product, it is also called 1,4 product. Why? Because this HBr is going to add this center, and this center is going to get, this center is going to H, and this center is going to get Br. This is 1, 2, 3, 4 position, 1,4 product, and this is called basically 1,2 product. Okay, you can have one question that here the two, in previous case the two double bond were similar kind of, here it is not similar, because this double bond is attached with two groups, and this double bond is going to is attached in two groups but in different carbon, so these double bonds are different. So you have to make all the possibility of carbocations, and after that find the most stable one. This is the case. Okay, uh you have to look upon another problem. I'm giving you question is, this is methyl actually, in this carbon this is methyl, HBr only, this is given. So try yourself. I'm writing the product. Product is again room temperature is given. That means no, nothing is given. That is room temperature. So this is going to be our thermodynamically controlled product. That's all. This is the actually critical part to tackle conjugated dienes. Okay. This is very simple, I hope. So next part is X2 addition. X2 addition. Here stereochemistry is very important. Okay. X2 addition, that means F2 or Cl2 or BR2, like this. X2 addition, X2 means chlorine, bromine, mostly these two. Okay, not fluorine and iodine. Okay. This addition is anti-addition. That means suppose I have given one alkene and I am adding X2, then these two X atoms is going to attach into this two carbon, and double bond is going to be converted to single bond, but this will attack through anti position, x x. So dihedral angle will be 180 degree, so they are oppositely attached. Okay, this will be product, not this will not be product. Okay, if you can think that these two are same actually, but in stereochemistry wherever these two will be different, okay, then this two, then we have to consider this only in case of stereo spatial problems. Okay, now how this occurs? Okay, suppose I have this alkene propene and I am adding bromine, reagent is given bromine CCl4. First what will happen, this alkene bromine will attach like this. Now bromine is non-polar molecule. Okay, but this double bond is going to polarize this bromine. So this double bond electron pair, lone pair, sorry, the electron pair in the pi bond is going to repel the bromine. For this repulsion, this bond will shift in this direction. So electronegativity of these two bromine in the reaction condition itself a little bit polarized, or dipole moment a little bit arise. It is dipole moment is zero. Normal BR2 is dipole moment zero, but here dipole moment arises temporarily. So this bromine is delta plus, this is delta minus. Now this alkene will attack. You can attack from there or there. Now lone pair of bromine will attack there. Okay, in any direction you can show. So our, and this bromine is going to remove. So this is Br plus. This is called cyclic bromonium ion. Bromonium ion. Cyclic bromonium ion. And this is very much unstable actually. Three-member ring. First of all, three-member ring. This is very much strained, and in that ring itself, in one atom there is positive charge. Okay, so cyclic bromonium ion. Now we have Br minus, another Br minus. Now how another Br minus is going to attack? In which carbon it will attack? In this Br plus, these two carbon center is partially positively charged, delta plus in this carbon and delta plus in this carbon also. But which one has more delta positive? Consider that this bond has broken. So this center is going to have complete carbocation, complete 2-degree carbocation. And this is going to have 3 plus 2, 5 hyperconjugative structure. But if this bond breaks, then this center will be complete carbocation, and this will going to have 2 hyperconjugative structure. Sorry, one hyperconjugative structure from this center. So this center will be more stable if it turns into more stable carbocation, this center. So what you have to do, you have to break this center. So this center positive charge is very, very high, because it has very high tendency to turn into complete positive charge, because turning to completely positive charge will give rise to more stable carbocation. So Br minus will attack to this center. It will not attack to this center. Okay. Now, if I write this bromonium ion like this, bromonium ion like this, here one methyl, here one hydrogen, here one hydrogen plus. So these two structure are same. This structure and this structure is same. Now Br minus will attack from this center from below the plane, and this will be above the plane. Now what we are getting, bromine is down, methyl is in right side, hydrogen is there, and here bromine is up and 2 hydrogen is there. That's why I have told you this is anti-addition. So this bromine and this bromine is anti by configuration, anti by conformation. Okay, so this is basically X2 addition and its stereochemistry. Now let's look into deeper in stereochemistry of this kind of problem. Let's watch very carefully. My question is this one, bromine. Okay, if we okay, this bromine. So first bromonium ion will form. Suppose methyl is up and bromonium is in down. So bromonium ion is forming from downward. Or the possibility is bromonium ion is upward. Here methyl is down. Okay, no problem. Now more stable carbocationic center is, more stable center is this center, this center. So next Br minus is going to attack there only, right? So product, so from where Br minus will attack, as bromonium is in below the plane, so Br minus will attack from above the plane. If Br minus attacks from above the plane, the above plane will be Br and down plane will be methyl. That center contains one methyl, this will go to down. And this center, as Br, this bond has broken, so Br is downward. Okay, this is one product. And from this center, similarly, bromine is up. Sorry, bromonium ion is up. So methyl is going to up. Bromine, Br minus is going to attack from downward, right? From downward, Br minus is going to attack. So downside Br, above side methyl will be rise to up, and this will also be up. Okay, because this bond is breaking, this bond retains. Okay, so the Br will be coming to the above side, Br plus. So these are two products possible here. Okay, let's go to a little advanced. Now I am not leaving this to possibility, I am restricting the possibility. Suppose methyl is up and this is one double bond. Now we are adding Br2 CCl4. Now the above the plane for this methyl group, above the plane for this methyl group, bromonium will be formed in below the plane side. Okay, now which center is more delta positive? If this center gets positively charged, this is going to have 1 plus 1 2 hyperconjugative structure, and if this center gets fully double bond, then this is going to have 2 plus 1 3 hyperconjugative structures. So this center has delta positive more. So Br minus is going to attack from there and from above the plane, as bromonium is below the plane. So above the plane, this Br will be above the plane, and this Br will be below the plane. This is, and here methyl will be above the plane. Okay. So in exam, they can ask you RS configuration of these two center. Okay. So you can clearly find it out. Okay. Now, I have another question for you. Try yourself at home, obviously. In some questions, in sub question, they can give you bromine water. What you have to do for bromine, first you have to make bromonium ion, cyclic bromonium ion. Okay. Next, attack. Br minus will not attack, rather water. That means OH2 will attack. Okay. The nucleophile, this bromine will be replaced by OH2. That means the second step OH will be there. Okay, so two nucleophiles, that means two atoms that is attaching here. One is Br, one is OH. So in bromine water case, you have to proceed accordingly. Okay, question is, N, the center is N, there's one double bond, NH, double bond O. This is your question. Bromine CCl4 is your reagent, and I'm writing the product, which you have to do yourself. What you have to do yourself, this one. This center is nitrogen. So this is going to be your final product. No, one bromine is there. This center will have bromine. Okay. Another question, homework. A reagent is Cl2 Ki CCl4. What you have to do? First, cyclic chloronium ion will form, not bromonium, cyclic chloronium. So three-member ring will, with chlorine, this will form. Then nucleophile will be Ki, that means I minus. Then I minus will attack. Okay. In normal Br2, first bromonium ion forms, then Br minus attacks. In bromine OE water, first bromonium ion forms, then water attacks. In here, chlorine means not bromonium, here chloronium ion will form, and further attack will be done by I minus, that is nucleophile. So this will be leading to finally this product. Mm, sorry. First bromonium will be like, there will be two product like this. There will be two product. First chlorine, and then I minus will be attacking from there. In the first case, similarly here you put just I minus. Okay, then the possibilities. Then these two product will be formed with one I actually. This Br minus if you replace by I, then similarly this two type of product is going to form. But the stereochemistry is I'm going to give you a trick actually for the stereochemistry for some kind of problems. Now, suppose my alkene is this, and I am giving you Cl2 CCl4. If in the question product stereo is asked, that means either this product is going to be meso compound. Meso compound means this is going to have plane of symmetry or center of symmetry. So if plane of symmetry or center of symmetry present in a molecule, this is meso compound. So product may be meso compound or product may be optically active. Optically active. Meso means optically inactive. And second one is optically active. It is also called DL pair. DL pair. Okay. That means DL pair means one product, this is optically active, then its mirror image, it is also possible. Its mirror image will also possible. So this is actually two product, one D, one L. If you have read the small d and small l nomenclature, you can understand this. So one product is meso product, another set of product is DL pair. So what product it is going to give? So first go to the conventional way. If you forget, I don't rely on trick because you can forget this. So first make one chloronium ion like this. My alkene is like this. Make one chloronium ion. What will happen? Suppose this is chlorine plus, and here methyl hydrogen, here methyl hydrogen. So this is trans configuration. From trans configuration we have started. This is chloronium ion, and now Cl minus again going to attack. So Cl minus is going to attack here. This will be up. So Cl methyl hydrogen, Cl methyl hydrogen. This molecule actually has center of symmetry because this chlorine matches, this hydrogen matches, this methyl matches. So center of symmetry. Again, you can have a plane of symmetry if you rotate the front carbon by 180-degree. What happens? H methyl, then Cl methyl hydrogen. So this here you can have one plane of symmetry, right? So this is meso compound actually. So the rule is ATM rule. I will call it as ATM rule. A for anti. This is trans. M for meso. Anti means anti-addition. We know Cl2 addition is anti-addition. Anti-addition. In many reactions, you can observe that is syn addition. For example, KMnO4 addition, osmium tetroxide addition. These are actually syn addition. So in chemistry, there are syn additions also. Here it is anti-addition. For those cases also, this rule similarly applies. Anti-addition of trans alkene will give meso product ATM. If anti-addition of trans compound give meso product, then anti-addition of cis compound will give DL pair, right? So from ATM only, from you have to remember just ATM. You can make all the conclusions from there. Okay. So from this you can solve this problem also. This question solve yourself. But one more thing I'm going to tell you. One very important thing. Here the two type of product possible. One is meso. This is optically inactive. And second DL pair. That means I have said that this particular one product, if it is D, if it is optically active, if only L is formed. Oh, sorry. Okay, so I have lost of those all board works. Okay, I hope you have written all of those. Okay, I'm telling you again. Okay, from where put an end. Okay, so anti-addition, in this reaction we are going to have anti-addition only. Anti-addition of trans compound is going to give meso, and anti-addition of cis compound we are going to get DL pair. So one is D, one is another one is L, small l. D means dextrorotatory or plus rotation. It is minus rotation or levorotatory. Now meso compound means this is optically active. Now this D and L is going to form in same amount. In same amount. That means in the reaction mixture, one possibility is all meso. That means optically inactive. Another possibility is same amount is formed. So this 50% is D, 50% is L. So suppose 50 molecules are D, 50 molecules are L. So this is actually racemic mixture, isn't it? So overall, it is also giving zero optical rotation. So this is also the mixture is optically inactive. You have to consider the statements in question, that overall solution optically active or inactive, or the product itself is optically active or inactive. Here product is optically inactive. Here product is optically active, but overall solution is optically inactive. Okay, so this is very important thing. Okay, our next addition is, let me make another diagram. Oh, sorry, home slide. I have to increase the number of slides, and here we're going to learn NBS addition. NBS addition. Full form of NBS is N-bromosuccinamide. Structure is, actually this is succinic acid. Succinic acid. Okay. If you add ammonia, so this is going to give you NH. This is succinamide. Succinamide. Okay. This is actually slow bromine source. Slow bromine source. This releases bromine slowly. And from here, mm, if it is succinamide, NBS, N-bromosuccinamide is hydrogen is replaced by bromine. N-bromosuccinamide. Double bond O, N, Br. This is N-bromosuccinamide. This is bromine source. In light or heat, this releases Br dot radical. But normally, in normal reaction, it gives Br plus slow. Okay. What will happen? Suppose NBS water in a reaction, in this reaction, reagent is NBS water. The same reaction is given by, suppose, BR2 water. The same thing will happen. First NBS will leave Br plus. So this is bromonium ion. Bromonium ion will form. Then water will attack to this center, and basically we are getting BrOH over there. This type of compound, in the same compound, in the same structure, if Br and OH both are present, the structure is called bromohydrine. Bromohydrine. Bromohydrine is going to form. Okay, I hope it's clear to you. And let's do last question of NBS. This is phenyl methyl NBS water. Now there is a first, what will happen? First, bromonium will form. Here is methyl, here is phenyl. Now, which center is more carbocationic? You will find if this bromine removes, then this center, this positive charge will be stabilized by phenyl ring resonance. Okay, for resonance stabilization, this center is more carbocationic. So water will attack simply here. Bromine will remove. In stereochemistry, everything all are same actually. Okay, and not 6 member, it is 5 member. Methyl, bromine, phenyl, OH. This is going to be our product. Okay, I think these things are clear. In the next session, we will be covering hydroboration oxidation. Hydroboration oxidation. Next, we will be covering oxymercuration, demercuration, and its special cases. Next, name reaction. In the next lecture, we will be covering these two, and after that, we will be covering two name reactions associated with this. This is pinacol-pinacolone rearrangement, and we are going to cover pinacol-pinacolone rearrangement in three type of system, plus rigid system, plus in cyclohexane system, plus in oxidant system, everything. Next one is dienone-phenol rearrangement. Dienone-phenol rearrangement. Okay, thus we are going to finish this carbocation. So we are ending up the lecture. So hope you have understood it. If you have any problem in any section of this lecture, let me know. I will try to cover that. Okay. Till then, goodbye.